Okay, so we are finishing our unit on word problems today. So we have just a few to solve. We're going to start with the starter and go over that. So we need to read the problem first. It says, determine if there are any 3 consecutive integers that can make a right triangle. If so, justify your answer and give the 3 sides that make it so. So let's look. What do you see that's important? Consecutive integers, we talked about that a long time ago. We know that we need 3. We know that we are going to make a right triangle. We need to justify, that just means that we need to show our work and give the 3 sides. Now that we know what we're looking for, we need to find it. Since this is talking about a shape, let's draw the shape. So we need to draw a right triangle. We know that our sides on a right triangle are the 2 legs and the hypotenuse. Consecutive integers, we talked about a while ago. Consecutive integers are like 1, 2, 3, right after one another. So if our first one, let's call it x, what would our second one be? It would be the very next one. So how we write that in math is x plus 1. Now it said we needed 3 numbers, so we need 1 more. The next one would be x plus 2. Our goal is to get the 3 numbers, so we can use the formula that we use with right triangles, the Pythagorean theorem, which in case you forgot is a squared plus b squared equals c squared. So we need to plug those in. The 2 legs don't matter where they go in the formula, but the hypotenuse is the longest side. So we have to choose the longest side out of our 3 numbers, which would be the last one, x plus 2. So now let's plug everything in. Let's call A, B, and C. When we plug them into the theorem, we get x squared plus x plus 1 squared equals x plus 2 squared. Now remember squaring from yesterday when we have 2 terms. We're doing x plus 1 times x plus 1, which means you need to distribute, not just squaring x and squaring 1. So the x squared will stay. And then we have x plus 1 times x plus 1. So we'll have x times x, which is x squared. We'll have x times 1, which is just 1x, times 1 and x. We have another 1x. And then 1 times 1 is 1. Equals, all of that will equal, we need to square x plus 2. So we have x plus 2 times x plus 2 is x squared plus 2x plus 2x plus 4. When we combine like terms, we can combine these and these and these. So our new equation would be, since we have 2 of these, we would have 2x squared plus 2x plus 1 equals x squared plus 4x plus 4. Now we need to combine across, and we will move everything to one side. So you can move to the left or the right. It doesn't matter, you choose. I'm going to move everything to the left. So we're going to move x squared. So we have to do opposite operations, and the opposite to move the x squared is minus x squared. We have an x squared over here, so we'll combine it here. Minus 4x, minus 4x, minus 4, minus 4. Okay, I'm going to move these down. Sorry about that. So now we have, this will cancel, this and this. So we have a 0 over here. This will make x squared. These will make negative 2x, and these will make negative 3. Now we need to find factors of 3. All the options are 1 and 3. So to factor this, we split up the x. We need to subtract to a negative 2, which means the negative number is bigger. Plus 1. Now we have our factors, but we need the numbers that go with them. So we need to set each factor equal to 0. X minus 3 equal to 0. X plus 1 equal to 0. And solve. Now we know that our measurements, we cannot measure in negative numbers, so negative 1 is not our answer. So our first length is x. Let's look back up at the question and make sure we've answered it. We need to give 3 sides that make it so. So 3 sides that work. We have 1, we have x. X was 3. Our next side was 3 plus 1. The following side was 3 plus 2. So all 3 answers together would be 3, 4, and 5. And that's our answer.